probably the toughest concept to pick up in fractions is dividing them. But actually, if you picked up or understood multiplying fractions yesterday, dividing fractions should not be such a difficult task. All right, so what we're going to do today is be able to find the reciprocal of a fraction or a mixed number, okay, and also work out what the word reciprocal actually means. To understand that dividing fractions can be done by multiplying by a reciprocal, to be able to divide fractions, mixed numbers, and or whole numbers, giving the answer in its simplest form. Okay, so let's get into it. So what we're going to do first is look at an intuitive answer to dividing problems. So using your current knowledge of fractions, have a go at answering these division questions. So first of all, I'll just deal with some whole numbers. So just say this is 2 and this is 1. And my problem was 2 divided by 1. We know that the answer of that is 2 because 2 of these things here fit into here. I'm going to get 1 into 2 2 times. And fractions is the same. We think about fractions exactly the same. So if I've got 2/3, okay, 2/3, how many 2/3 am I going to fit into 2/3? So again, if you want to visualize this, this is 2/3 and this is 2/3. How many of them am I going to fit into there? Well, the answer is 1. Okay, so one lot of 2/3 goes into 2/3. All right, let's do this one next, I think. All right, we'll do this one next. We've got 2/3 and we want to divide that by 1/3. That basically is saying how many lots of 1/3 goes into 2/3. So here's 1/3 here. All right, that's 1/3. And there's a third and a third. So this whole thing would be 2/3. This thing here that I'm going to outline. And how many 1/3 am I going to fit in this 2/3? Well, I'm going to get one of them in there. That will go to there. And then I can squeeze another one in there. So the answer to this one here is 2. All right, what about 1/3 divided by 1/6? That is, how many sixths am I going to get into a third? Here's the sixths down here, and here's a third. So there's 1/6. And note that I'm going to get one of them in there and another one in there. The answer to this question is also 2. All right, if I've got 2/3, how many lots of 1/6 am I going to get into 2/3? Well, again, I've got 2/3 already here. Here's a sixth. I can see that I'm going to get 1, I'm going to get 2, I'm going to get 3, and I'm going to get 4. Okay, so the answer to this one here is going to be 4. So this is kind of like intuitive or visualization in terms of answering these questions. All right, what about a quarter divided by a half? Okay, so I've got a quarter here, and what I'm trying to do is put a half into the quarter. So how much of this thing here am I going to get into this? Well, it's not going to be a number greater than 1, like 1, 2, 3, 4, 5, 6, 7. In fact, I'm not going to get all of the half in there. I'm only going to get half of the half into the quarter. So the answer to this one here is a half. How about this? What we're trying to do now is put a third into a half. So here's the half. And here's the third. All right, so we can see here that I'm going to get one of the thirds in there. And how much more of that third in there? Well, I'm going to only get, if you can see by the sizes, I'm only going to get half more of the third into this part here. So the answer to this one will be 1.5 or 3/2. There is a shortcut to dividing fractions. And what we say is when the fractions aren't easy to think through, because a student will say, that's great, that method, Mr. Miller, but what if I had 3/7 divided by 15 over 32, for argument's sake? How many 15, 30, or I can't visualize that. Yeah, sure, I can't either. Okay, so That one there is a problem. So when the fractions aren't easy to think through, division of fractions can be completed by doing this, multiplying the first fraction by the reciprocal of the second fraction. All right, when we reciprocal a fraction, what we're doing is kind of flipping it. Don't know whether there's double P on that, but anyway, someone will tell me. So what we're doing when we're finding the reciprocal of a fraction is that we're putting the numerator where the denominator is and the denominator where the numerator is. All right, so how would this work? So can't use an equal sign. Examples of reciprocals. So 2/3 is our fraction and the reciprocal of that would be 3/2. Okay, notice what happens is the numerators and the denominators change place. This one here, we've got 3/5. So when I get the reciprocal of it, I'm going to say that the answer is 5/3. This one here, to do a reciprocal of a mixed number, we simply convert it to a improper fraction and then flip it, 7/10. So the example of the dividing fractions shortcut will be multiply the first fraction by the reciprocal of the second fraction. So that will yield exactly the same result as that. Now, why is that a good thing? Well, we already know how to multiply fractions. We did that in another lesson. So if I can convert the division problem into a fractions problem, then I can just use the skill I learned multiplying fractions and apply it to these problems. Now, many students go, oh, yeah, my teacher in primary school showed me that, and he or she said, stay, change, flip. And really, that's just a way of remembering the process, okay? So if you've heard that one before, what happens is that one stays, the division sign changes, so it goes from divide to multiply, and the second fraction flips, okay? So 4/1 becomes 1/4 becomes 4/1. So that's flipped. Okay, and then we go ahead and multiply, and if you look, we've got 1 times 4 is 4, 2 times 1 is 2, 4 divided by 2 is 2. So a half divided by a quarter is 2, i.e. 2/4 are going to go into a half. All right, so that seems like a convenient way of doing a problem. But the big question here is, why does it work? Why are you allowed to change a divide to a multiply? They seem like completely different signs. Why do you flip the second one and not the first one? And so here is the example or the working out I generally give to students to show them why it works. So let's take this problem that we already know the answer to. So it's a half divided by a quarter. Okay, that's the problem I'm going to work on. Now, what I'm allowed to do when I divide things, just say I've got 2 divided by 3, that's the same as the fraction 2/3. So I'm going to do the same thing with this. It might seem a little odd, but this actually is true. This is a half over a quarter, or a half divided by a quarter. All right, my next step here, so I haven't changed anything yet. I'm going to multiply it by 1, which we know doesn't change anything. So this is equal to this, which is equal to this. Now there's another way I can write the number 1. I can write it like this. So this is 4/1 divided by 4/1. So same fraction over same fraction means that this still is 1. Okay, so this seems a bit weird, no doubt. But anyway, what I'm going to do is look at this part of the fraction here, okay? So the lower part of this, I'm going to multiply that together. So in the top part here, I'm going to get a half and 4/1. They're still going to multiply. And what are both of them going to be over? Well, I've got 1 times 4, which is 4, and 4 times 1, which is also 4. So we can say that it's going to be a half times 4/1 over over 4 over 4. Well, 4 over 4 is just 1. And dividing by 1 doesn't do anything, so I can simply rewrite it as a half times 4 over 1. Now notice what's happened there. So if you were doing this problem using the kind of state change flip or multiply by the reciprocal idea, what you would do is say, oh, I know that. I know a rule for this. This is a half times 4 over 1. So that stays, that changes to a multiply, and that flips. And those of you who have picked up what's happened through this bit of manipulation or number manipulation will find that is exactly the same as that. So this process here, by doing this, essentially what you're acknowledging is that all of this stuff happens. All of this stuff takes place, but we can shortcut straight to there because this will work for any fraction that I do, and you should try it. 1 times 4 is 4, 2 times 1 is 2. The answer is 2. We already knew that that was the answer, but that's the handy thing about doing this process is we can see how the answer comes out. Okay, so that's an example of why it does work. You don't need to do all of this working each time. We just can go to this, straight to this here. But if anyone ever asks me, why can you just change a divide to a multiply? Why can you just flip that? And why does the answer work? Well, that's my answer. And you can do this working out for every single division problem and arrive at this same point here, which will be the multiply by the reciprocal point. So here's some examples. So 5 over 8 divided by 3 over 5. So what I know is that it will be true if I rewrite this as the first fraction multiplied by the reciprocal of the second fraction. We're going to yield the same result. And again, please go through those steps on the previous slide if you want to go through and work out how it works. All right, so now what I do remember is that I look up and down and see if the fractions can be simplified, and then I cross simplify and see if there's anything that can happen with that. There is absolutely nothing going on here, so we're going to go 25 over 8 threes are 24. You could leave it very comfortably like that, or you can convert to a mixed number if you want, unless the question says state your answer as a mixed fraction, in which case you have to do that. All right, let's go for this one here. So I've got 4/5 multiplied by 3 on 2. So that changes, that flips. Again, I implore you to maybe throw in the intermediary steps that I had on the previous slide just to see why that works, because it will work this time. It'll work every time. All right, so now what I'm going to do is see if I can simplify the fractions by going up and down. Can't, so now I'm going to go cross and have a look, and there is something I can do here. The 3 and the 5 I can't, but the 2 and the 4 I can. What I'm going to do is say 2 is the number that goes into both 2 and 4. 2 goes into 2 once, 2 goes into 4 twice. Let's go ahead and multiply now. 2 times 3 is 6, 5 times 1 is 5, 1 and 1/5 if you really want to put that into a mixed fraction. I'm going to write 3 over 7 divided by 4. I want to write that as a fraction because when I divide by a fraction, I know that there's a rule that I can use to help me with that, which is the multiply by the reciprocal. So I've got 3 over 7 times 1 over 4. Okay, can't simplify, can't simplify, can't and can't. So let's go ahead and multiply this out. 3 on 27, what am I writing? 3 on 28. Okay, let's go for it on this one here. So we're going to say that this is 24 over 1 divided by 3 over 4, which is the same as 24 over 1 times 4 on 3. Now, can't simplify, can do that, okay? So I think of a number that goes into 3 that also goes into 24, and if you're thinking it's 3, you'd be correct. 1 and 4, can't do anything with that. 8 times 4 is 32. So 3/4 will go into 24 32 times. All right, this one here, I think the best way to do this problem is to convert to an improper fraction. So 2 times 5 is 10, plus 2 is 12. on 5, divided by 1 times 5 is 5, plus 3 is 8 on 5. Okay, now what we're going to do is, because it's dividing by a fraction, we're going to change that to a multiply by the reciprocal. Okay, and now what we're going to do is see if we can simplify. There's nothing we can do in terms of the individual fractions, so then we go to cross and see if there's anything we can do there. 5 and 5, definitely. 5 will go, so a number that will go into both 5 and 5 is 5. 5 goes into itself once and into itself once. 5 goes into, no, 8 and 12 are my next two. What will go into 8 that will also go into 12? 2 will, but it's best to get the highest possible number, and that's 4. So 4 will go into 8 2 times, and 4 will go into 12 3 times. Now we can multiply this out safely. 3 times 1 is 3, 1 times 2 is 2, which is 1.5, or 3 on 2 if you want to leave it like that. All right, so that's the end of the work there, and your task today is to go through 4H.